Good evening. Today we are doing section 5-2, medians and altitudes of triangles. Reminder, yesterday we learned the circumcenter and the incenter of a triangle. Today we are continuing that list. So the median is a segment connecting the midpoint of a side with the vertex opposite. So in this triangle we have here, you can see that we clearly have three medians drawn, and those three medians are intersecting at a single point in the middle called the centroid. Each one of these lines goes from the vertex to the midpoint of the opposite side, and they intersect at the centroid. This is the balance point. If I wanted to balance this on my finger, this is where I would need to place my finger. The theorem states the medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. This is called the centroid. So in this triangle ABC, P is the centroid. So that means that AP is 2/3 of the length from A to K. And BP is 2/3 the length of B to L, and CP is 2/3 the length of C to J. The centroid is the balance point of the center of gravity. Centroid is the one that usually appears on every Regents exam. The altitude is the perpendicular segment from a vertex to the side opposite. So in this triangle, there are three altitudes. Since it is a right triangle, two of the altitudes are the sides. When I draw them, they intersect at the point called the orthocenter. The lines that contain the altitudes of a triangle are concurrent at the orthocenter. The orthocenter is the one that is the least special. So on coordinate geometry, if I have the vertices of the triangle graphed as here, VGH, and I want to find the coordinates of the orthocenter, what I need to find is the three altitudes of this triangle. So the easiest altitude is to find H to the segment FG. That is just this vertical line, which has the equation x equals 1. To find the other two altitudes, I need to find the slope of GH, which is 2, and therefore the perpendicular line would be 1/2. Now, negative 1/2. And so it's going to go from F, and it's going to have a slope of negative 1/2, so that's down 1 over 2, down 1 over 2, down 1 over 2, and so that is this line right here. And you can see that they intersect right around there. To do this algebraically, I would write the equation of each line, and then I could set them equal to each other, solve the system, and find out that they cross at the point of 1, 5/2, or 1 and 2.5. Now I realize I clicked through this rather fast. If you need to slow it down, certainly please always feel free to pause the video. So at the right here I have a triangle ABC that I have graphed, and I would like you to find the coordinates of the orthocenter. Please pause the video, find that, and come back to find the answer. Welcome back. The answer to the point of intersection of that orthocenter is negative 4/5, 4 4/5. If you have any questions about this, please bring them into class tomorrow. Here's a review of what we've learned so far in this unit. The perpendicular bisectors will intersect at the circumcenter, and the circumcenter is equidistant from each vertex. The angle bisectors intersect at the incenter, and the incenter is equidistant from each side of the triangle. The medians intersect at what we call the centroid, and the centroid is 2/3 the distance from each vertex. The last one is the altitudes. They intersect at the orthocenter. And there really isn't anything special about that one other than the point of intersection. Please remember to bring your books tomorrow, and have a great night.